For centuries, we assumed that technological progress followed a straight, predictable path. Simple tools evolved into complex machines. Craftsmanship slowly turned into industry. Each generation improving just a little upon the last. But history tells another story. Across the last 500 years, a handful of creations appeared long before the world was ready for them. Devices so precise, so efficient, and so radically ahead of the tools available at the time, that modern engineers still struggle to explain how their creators achieved such mastery. These weren't prototypes. They weren't experiments. They were breakthroughs, complete systems built with confidence and clarity. As if their inventors could see a future no one else imagined. Today, we explore 6 real machines that arrived too early. Machines that changed their industries, their nations, and eventually, the world. Machine 1, Cornelisson's wind-powered sawmill, from 1593. Before this invention, cutting timber was an exhausting ritual unchanged for thousands of years. Teams of craftsmen worked in pairs, sawing logs by hand, inch by inch, day after day. Shipbuilding depended entirely on this slow, grueling process. Then, in 1593, Cornelis Cornelisson attached a crank mechanism to a windmill. And everything changed. For the first time in European history, wind power drove a mechanical machine tool. The rotating shaft of the mill translated into a vertical sawing motion. Lifting and dropping blades with precise, rhythmic force. A feed mechanism advanced the timber automatically. What once took weeks could now be done in hours. Production multiplied more than tenfold. Shipyards accelerated. Trade expanded. And the Netherlands quietly stepped into its golden age. Looking back, historians consider this invention not just a clever idea, but a spark. A moment when the industrial age almost began 2 centuries ahead of schedule. Machine 2, Portsmouth block-making machinery, from 1803. Long before Ford, long before assembly lines became symbols of modern industry. Marc Isambard Brunel and Henry Maudslay built something extraordinary. A fully mechanized factory. Inside the Portsmouth block mills, 45 specialized machines worked together with astonishing harmony. Boring tools, rounding tools, shaping machines, drilling mechanisms. Each performing a single task with accuracy that seemed impossible for the early 1800s. With fewer than a dozen workers, the factory produced more than 130,000 pulley blocks per year. The same output that once required more than 100 craftsmen. This wasn't just efficiency. This was mass production, before the world even had a word for it. Modern engineers studying the machines often describe them using the same phrase. Too modern for 1803, almost suspiciously modern. Machine 3, Maudslay's screw-cutting lathe, from 1797. Before Henry Maudslay, precision barely existed. Screws were handmade, each slightly different, each incompatible with the others. Machines could not rely on interchangeable parts. Because nothing was truly identical. Maudslay solved a problem that no one else could even measure. His screw-cutting lathe linked the rotating spindle to the cutting tool through a master lead screw, allowing threads to be carved repeatedly with the same pitch, depth, and geometry. One idea, one mechanism, unlocked the entire age of precision engineering. What astonishes historians even more is that Maudslay crafted the original master lead screw by hand, achieving tolerances admired even today. It wasn't just a machine ahead of its time. It was a machine that created its time. Machine 4, Ramsden's dividing engine, from the 1770s. At a time when most craftsmen marked measurements by eye, Jesse Ramsden built a device capable of dividing circles into microscopic, mathematically perfect increments. His dividing engine engraved sextants, octants, and scientific instruments with such astonishing precision that navigation accuracy improved across entire oceans. The British Board of Longitude considered the machine so important That they funded its construction on the condition that Ramsden could not keep it secret. The engine belonged to science. Too valuable to remain in the hands of one man. Modern engineers examining the device often ask the same question. How did Ramsden achieve such precision without precision tools? When those tools didn't even exist yet? A machine ahead of its era, built with methods lost to time. Machine 5, Wilkinson's boring machine, from 1774. Before Wilkinson, cannon barrels were drilled from the outside in. The results were unpredictable, uneven walls, misshapen cylinders, dangerous flaws. Wilkinson reversed the logic. He fixed the boring bar in place. And rotated the massive cannon around it. The result was revolutionary. Cylinders with straightness and uniformity that engineers had never seen. This wasn't just a military innovation. Wilkinson's technique produced the perfectly bored steam engine cylinders. That James what needed to transform the world. Remove this machine from history. And the steam age collapses. Machine 6, Swiss automatic lathe, from the 1870s. At first glance, the Swiss automatic lathe appears delicate, almost fragile. But inside its compact frame lies one of the greatest achievements in microengineering. With a sliding headstock and guide bushing, the machine could cut parts smaller than a grain of rice. With tolerances so tight that even modern CNC designers studied its logic. Swiss watchmaking exploded. Medical devices evolved. Aerospace components shrank. Entire industries were built on the precision this machine made possible. And remarkably, the core concept remains unchanged today. Because the original design was already perfect. Looking at these 6 machines together, a pattern emerges. They didn't belong to the centuries in which they appeared. They belonged to the future. Their creators saw possibilities no one else could imagine. A world shaped not by brute force, but by precision, intuition, and craftsmanship that bordered on genius. These machines didn't just perform tasks. They shifted timelines. They accelerated history. And they remind us of a truth often forgotten. Progress is not always gradual. Sometimes it leaps. Sometimes it surprises. And sometimes it appears in the hands of a single mind, who sees the world differently. These machines were too advanced for their time. But perhaps their time is still coming.